Dear students, today we are going to see what is Unit 5 of AML, that is Ensemble Learning. All of you are familiar of a cricket team. In cricket team, we have batsman as well as bowler. And again, some bowlers are divided into category like a fast bowler, spinner, like this. So in one team, variety of people are there who are proficient in different playing skills of that cricket. Okay, then only when a team is formed with a combination of such people, then only team can perform well and it can give its best performance. So in the same way, when we are trying to develop a ANN model or a neural network model, then we want the best performance of that model, where we want to combine multiple algorithms together and we want to take the advantage of each of these algorithm and we want the best performance. So that is what our ensemble learning. Okay. Now, as you can see here, kids will play some game na, in which they are attaching parts together. Same thing we are doing in ensemble learning. We are dividing our data and each subset of the data will be given as an input to each of the machine learning algorithm. And finally, whatever is the output of these algorithms that will be combined together and that is known as a final prediction of our model. Okay. Now, as I told you, ensemble learning is combining the multiple models together in order to produce the improved results. Okay. And because of this, we are getting more accuracy in our solution. Okay. Because when you are using only one model or one algorithm, then it may have some advantages as well as disadvantages. So we want to overcome the disadvantages of that algorithm by another algorithm. That's why by combining these algorithms together, we will achieve an ensembled model. Okay. Now, what is our main target here? Whatever is your variance or bias generated by the algorithm, we want to reduce that. Okay. Then only model performance will be increased. And here, the algorithm that we are going to implement using ensemble learning is random forest algorithm. Okay. Now, what do you mean by a regularized model? The model that is having best fit is known as a regularized model. Means model that is not experiencing overfit or underfit. The model in which both bias and variance are minimized. That is known as a regularized model. Okay. Now, when you are having a bias, then what do you mean by that bias? Bias is the difference between your predicted value and the target value. That is, bias is just like your error of the prediction. Okay. Now, when you are having high bias means what? It is indicating the large error. Means what? Your data is not trained properly as well as it is not able to get tested properly. Means your model fails in both the phases, training phase as well as testing phase. So this concept is known as underfitting. Okay. Means because of bias, what error we are getting, that is called as a underfitting. Now, what do you mean by variance? Variance means what? What is the variety of data that you are inputting to your model? That is known as a variance. Now, what is the problem with the variance? When it is high variance means what? It is working very well during the training phase. But during testing phase, your model is generating more errors. Okay. During testing phase, your model is getting failed. So such model is known as overfitted model. So what you have understood till now? In your model, if you have bias, then it is underfitted model. In your model, if you have variance, means what? It is overfitted model. Now, both the models are not useful to us. We want a best fit. Then in that case, what we have to do? We want to reduce our variance as well as we want to reduce our bias. But when your algorithm is simple, then in that simple algorithm, we are having high bias and low variance. But when your algorithm is complex, then it will have high variance and low bias. At a time, your algorithm can't be simple as well as complex. Means at one time you can't have low bias and low variance. So this concept is known as bias variance trade-off. Okay. So to overcome on this trade-off, we are preferring the option ensemble learning. Now, as we can see in the model of ensemble learning, you are having this original data set here. Now that data set will be splitted into the subsets. Now each of the subset will act as an input to your classifier. Okay. Now each classifier is going to produce some prediction. So all of these predictions will be combined together in order to get the final result. Okay. Now in random forest, how we are generating the forest? By combining many trees. So in our machine learning, we are having a decision tree. So multiple decision trees are combined together to generate the random forest algorithm. Because the prediction that I'm achieving from one decision tree is not satisfactory. I want to improve that results. I want to improve the accuracy of my model. So that is possible using random forest. Now, the next question comes to our mind is how we are going to combine the predictions. So for that purpose, we are having two techniques. One is known as a voting, another one is known as a averaging. Now, in which case you will go for voting? Voting is used for the supervised algorithms in which we are classifying the data. And averaging is used for the supervised algorithm in which we are performing the regression. Okay. Now, again, you will have types of voting and averaging. Now, the first type of voting is the majority voting. So what we are doing in majority voting, suppose there is a group of friends and for them there is a problem. Means, the question has came that to which place we should visit on this weekend. Then out of 10 friends, if 8 friends have preferred one place, then we will prefer that place only. So that concept is known as a majority voting. Means the predictions which are more than the half of the votes. Means half of your models. Suppose you are using 4 models. Then 3 models are giving you that the particular data sample is belonging to the class 1. Then in that case, we will consider the prediction as class 1 only. Because here we are having more than half votes to the class 1. So such concept is known as a majority voting. Now what we are doing in the weighted voting is each voting is given the importance. Means each model is given the importance. So based on that importance only, we will consider that model's prediction. Means the model with higher importance, that model's prediction will be considered. Okay. Now what we are doing in the averaging, there are two types of the averaging. One is a simple averaging in which, suppose you are having 4 models, then simply you will add P1 to P4 and divide it by 4. So that is known as a simple averaging, and generally it is used for the regression in which overfit is reduced. Okay. Now the next one, very important, that is the weighted averaging. Means here, simply we are not adding your predictions and dividing it with the number of models. But in weighted averaging, what we are doing is each model's prediction is multiplied by weight. The weight is assigned based on the importance of that model, the efficiency of model, the advantages that we are getting because of that model. And then only you have to calculate the average. Okay. So in this video, what we have seen, what do you basically mean by ensemble learning, then how we are combining the predictions of ensemble learning using the voting and averaging. Now, why we are going for ensemble learning? Because we want to reduce the bias and variance. And we know that in one model, it is not possible to reduce both bias and variance. So there is a trade-off between these two variables. To overcome that trade-off, we will go for the ensemble learning. Okay. Thank you.